So this is our first Python notebook that we're going to take a look at. As we said, you can see the name of the file up at the top. We can connect it to a runtime. We have different markdown blocks, and we have, we're going to have code blocks down below. We can see an outline at any time by hitting the little outline button on the left, and that can be pretty useful, so we can kind of step through this as we need to. Here's some of the history on Python, what Python is. If you looked at some of the previous videos, you probably already saw a lot of this content. And then Colab, Colab is actually built on top of an application called JupyterLab. JupyterLab is an open source project that allows you to create this interactive browser-based environment for mixing code, documentation, and output. We're going to take a look at this. We don't have to build a web server. We don't have to set up anything. We can just kind of work with our Python code. So if we start with basic Python arithmetic, you can see here, this is all going to be valid Python code. One thing that you'll notice is there are no semicolons or anything at the end of the lines. And if we hit run, it's going to connect to a runtime for us automatically. So you can see here a little bit of detail on that. And 1 plus 1 obviously equals 2. So, okay, everything checks out so far. And then you can see we can add together multiple numbers. So basic arithmetic, we run that, and you'll see 7 plus 2 plus 4 plus 6 definitely equals 19. We can do more than addition. We can also do subtraction. So you can see that's going to come out to be 77. And we can mix all of this up. So we can 100 minus 23 plus 7 minus 4, that's going to come out to 80. It follows the order of operations just like you would expect. Addition and subtraction proceed left to right. And you can change the order by using parentheses. So you can see here 23 plus 7 is going to finish first, and that's going to be 30. Then 100 minus 30 minus 4 is going to be 66. Just like many other languages, you use asterisk to multiply. So if we run that, we're going to see 415 plus sort of the double error double precision error that you see here. So it's almost 415. It's almost exactly. But many languages have this sort of precision error, and I think that's what you're seeing right there. You can also mix all of these arithmetic options, so it's going to be the same order of operations as you typically would see in programming languages. Multiplication first, multiplication division first, and then addition and subtraction. So we're going to get 2 times 10, which will be 20, and then 18 over here, so it'll be 20 minus 4, which will be 16, and then plus 3 or plus 18, which should be 34. There we go. All right, I'm still young enough to do math. Awesome. Division uses a forward slash in Python, so we hit that and you can see 40 divided by 3, 13.333333. Ultimately we're coming out to about 13 1/3 there. And then integer division, where we drop that remainder, we use 2 forward slashes. This is also called floor division. So if you ever hear, I actually recently heard floor division for the first time. I've been programming for most of my life, and I find I just heard floor division. But integer division versus floor division, double forward slash if you want to use this. Back in Python 2, it was default integer division. So this allows us to, that's one of those ways that it's not quite backwards compatible. Comments are simple in Python. You'll see a lot of these # comments. This is actually called an octothorpe. It's actually got a name. Most people don't really recognize that. They just call it the number sign and the $, but it is an octothorpe. This is how you create most of your Python comments, and these are single line comments. Just like in Java, you might see 2 forward slashes to show a comment line. In Python, we have multi-line comments with 3 single quotes. So if I run this first one, you're going to see it's a comment, nothing actually happens. But kind of a weird thing about Python is if I run this second one, it's actually going to show me that second value. And that's because in Colab, it's any literal that I put in or a variable that I just sort of say its name, it's going to output that. And in Python, 3 single quotes or 3 double quotes do identify a comment, but they also make a valid multi-line string. So that's why this kind of comes out that way. Kind of use those interchangeably. Now we do have variables in Python. We can set the variables, and you can see there's different types here. So num equals 4, that means num is an int. We have word equals cats, so word is a string, and then other num is 3.2, so that's going to be a float. Here we go. If we run this, you're going to see 4 cats. So one thing that's a little bit different from some other languages is that Python will not explicitly convert your numbers to concatenate them with strings. So you can see here sentence equals str. Str is a function that forces the number here to become a string. And then when we put sentence in just to show the value of that, you can see 4 cats. And if you don't believe that that's not the case, if we comment out this line and hit or try to run it, you see we actually get an error. It's going to say, oh, that's not okay. So in order to make that work, you have to have this string around it. So if we'll go ahead and recomment that, and then it should give us, yeah. I don't really like those red, that red thing. It really bothers me. Got to get rid of that. Too obsessive to leave that alone. So we also have a couple of data types here. So we saw int, we saw string, we saw float. We also have bool, which is just short for Boolean. Just like int is short for integer and str is short for string. So these are the actual types here. If I run this code, nothing really happens. But if I don't run this code, then these down here are not going to give us what we expect to see. So you can see A is an int, B is a bool, C is a float, and D is a string, str, just like we set up here. So nothing too surprising there. Python does not have a character type. It's only strings. So the type of a single character is just a string. Yeah, all of these, so here we go. And we also have an is keyword. We're just going to kind of throw that at you out of the blue. Type C is float is going to be true. So you can check types using this is keyword. And then in Python, we have none. We don't use null, we use none. If we see the type of none, it's going to be none type. So we print in Python instead of, if you want to print multiple things, if we print the values here, we see the values. That way we don't have to just rely on the Colab mechanism to just kind of echo out whatever that value is. We can see 7, true, 9.3. So we can print those out directly. Now, we also have Boolean operators, just like we have in many other languages, greater than, less than, equal to, not equal to. 3 is greater than 5 is going to be false. 12 divided by 2 is equal to 6. Well, that's actually going to be true. 12 divided by 3 is not equal to 4 is going to be false. And 7 is less than or equal to 3 is going to be false. So, nothing too surprising there if you're familiar with other programming languages. The one difference, though, that you might see from other languages, especially Java, the true-false literals here, they are actually with capital letters. So you can see each one of these, capital T, capital F. If you make this lowercase, Python doesn't know what to do with it. It's like, what does that even mean? So that's actually not a valid keyword. We have to make it the uppercase for it to work. And Python, instead of using pipes or ampersands, actually uses spelled out words and an or. Even though it's a terse language, sometimes they do spell things out. So here we go. M and P, if we look at this, true and false is going to be false. M or P, so true or false is going to be true. M and N, well, those are both true, so that's going to be true. And P or Q, that's going to be false. So just follows the typical Boolean algebra as you might see in other languages. Same true and true is going to be true. Anything, true in anything else, or false in anything will be false. True or anything will be true. So basically true and true is the only thing that, for the keyword and, is the only thing that's going to end up being true. And false or false is the only thing that will end up being false for the or keyword. You also have not for negation, so you can see here true, false, so M or not P, M and not N, so you can kind of see how that works. And you can modify this code and play around with it to your needs, so just so you can kind of explore the language and try things out. There are also strings and substrings in Python. So in Python we have strings, and we can print those, and you can see double quotes and single quotes. Either one of those works fine. You don't have to choose one and then use exclusively that one thing. You can use either one. And then we don't have a length method or any other method on our string to see how big it is. We have to use this len function, which you'll see come up a lot in Python. So the length of all of the alphabetical characters, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, that's going to come out to 26. So hopefully everyone knows there are 26 letters available there. You can also access your individual characters like an array. So S0 is going to be A, S12, the actual 13th letter of the alphabet, is going to be M. So you can kind of see how that works. And then Python has this idea of slices, which are a bit different from Java, but you can treat arrays, or treat your strings like arrays, and access individual characters or substrings. So if you're familiar with the Java substring method, this actually works exactly the same way. 2, 4 is going to give you a string of size 2. It's going to be CD, so position 2 would be, position 0 would be A, position 1 would be B. So 2, 4, when we're working with this string S that contains the entire alphabet, is going to give us CD. And then if we go to the end, 20 through 25, we're going to get UVWXY. And if we made it 20 to 26, you can see that's going to give us all the way up to the end, all the way up to Z. So, kind of a nice shorthand for using the substring method there, what you might expect from the substring method. You can also leave values off of these, so you can say 13 up until the end. So that way, there we go, 13 up to the end, so N all the way up to Z, and then, or you can omit the first value and you can see everything up to the 8th value. So that's going to give us 8, A, B, C, D, E, F, G, H. And you can use negative numbers to access values from the end of the string. So -1 is going to give you Z, -3, and you can incorporate that into slices as well. So if we did something like print S -3, you can see that's going to give us, instead of Z, that's going to take us back to X. And then you can incorporate that into slices. -3 up to the end is going to give us X, Y, Z, or the beginning up to -4 is going to give you everything but W, X, Y, Z. So you can kind of see how that works. And like I said before, multi-line comments are actually valid strings. So, if you have a multi-line comment, you can see it takes up all the space. When we output that, we get this long string here. And you can see it's actually giving us our escape characters in this output. We didn't explicitly type those in, but it's just kind of showing us that they're there. All right, and type conversion. So we do have to use type conversions. Python doesn't allow us to convert all variables or all values, all variable types to different variable types. So if we convert a float to an int, you can see that just truncates. It doesn't round. If we convert a y we can take a float and make that another float, or we can say, we can make this a float too. Not that it'll really change much, but we can run that and you can see it's still the same. And we can also convert numbers to strings so that we can actually concatenate them with strings. So typically you don't see concatenation of strings in Python like this. What you usually see is this the percent sign, typically the modulo operator. It's going to actually insert this value into your string. So one possible number is 3. So you can see it kind of works the same way as that one. Now, there are a couple of different exercises here that you can try at your own pace. These aren't graded or anything, but they'll give you a chance to explore Python and try a couple of things out. So go ahead and take a look at those. Thanks for watching. Hopefully some of this Python content was useful, and we'll get into some other things like if-else statements in the next video. Thanks.